All right, let's dive into network security today. But not just any network security, the stuff you need to know to ace the CCSP exam. We're going way beyond just knowing what a firewall is. We'll cover DMZs, those super specific firewall rules, and how all of that translates to the cloud with network security groups. It's about understanding not just the definitions, but how all this stuff actually works in the real world. And of course, how all of this fits into that bigger picture of cloud security that the CCSP exam is all about.
Yeah, it's definitely not just about memorizing terms for this exam. You have to really get the concepts of the why behind the what. Like with firewalls, everybody says they're like a security guard, right? But the CCSP wants you to go deeper than that. So think about it. If the firewall is a guard at the front door, then the DMZ is like a security checkpoint outside of the main building.
Okay, I like where you're going with this. So you're saying the DMZ is like a buffer zone. It sits between the open internet and your sensitive internal network. That way, even if somebody gets past the firewall, they're still stuck in that outer area. They can't actually get to the really important stuff.
Exactly. And this idea is so important for the CCSP. They want to make sure you understand why this layered approach is so vital for security. You're not just blocking everything at the front door, you're creating a whole line of defense that limits the damage, even if something bad does happen.
So the firewall is the first line of defense, and then the DMZ is sort of a containment zone to limit the blast radius if something gets through. But let's get down to how firewalls actually control traffic. What's the deal with these firewall rules I keep hearing about?
Firewall rules are basically the instructions that you give the firewall. They tell the firewall what traffic is allowed in and what should be blocked. And each rule is really specific. Like you have to define the source of the traffic, where it's going, the port it's trying to use, the protocol it's using. And then the most important part is whether to allow that traffic or deny it.
Okay, so it's not just a block everything or allow everything situation. It sounds like you can really control the traffic using these rules based on a bunch of different criteria.
Yeah.
So let's say I have a web server in my DMZ. What kind of rule would I need to set up so that people on the internet can actually visit my website?
So let's say your web server's IP address is 10.15.100011. You'd create a rule that says, hey, firewall any traffic coming from any source.
Yeah.
We want the entire internet to see our website.
Right.
That's headed to 10.15.100.1 on port 80. That's the standard web traffic port. Using the TCP protocol, go ahead and let that through.
Okay, so you're literally spelling out what traffic is allowed and what's not. What happens if you forget to make a rule or some weird traffic tries to get through? Does the whole network just burst into flames?
Not quite. That's where the default deny principle kicks in. This is the firewall safety net. If there's no specific rule that allows the traffic, it just automatically gets blocked. And this is so important for security because it blocks anything you haven't specifically allowed, even if you didn't think about it ahead of time.
So it's like having a really strict bouncer at a club. If you're not on the list, you're not getting in no matter what. And this default deny thing, that's a pretty big deal for the CCSP exam, right?
Absolutely. Default deny is like a core security principle, and it shows that you're thinking about security in layers. The exam really wants to make sure you're not just relying on one security measure. You have to build in multiple layers of protection.
Okay, so we've covered firewalls, DMZs, and default deny. That's a good start.
Yeah.
But obviously things get a lot more complex when we start talking about the cloud. It's not like we can have physical firewalls sitting in a data center that we don't control, right?
Right, you're sharing infrastructure with other customers in the cloud. So if everybody was messing around with the main firewall, it would be total chaos. Cloud providers solve this using network security groups, or NSGs for short. These are basically the cloud's version of firewalls. They give you control over your little slice of the cloud without messing up security for everybody else on the platform.
So it's like having your own little mini firewall that you manage within your part of the cloud.
Exactly. And the good news is that setting up NFG rules is pretty similar to setting up regular firewall rules. You define the source, the destination, the port, the protocol, all that stuff. The main difference is that in the cloud, you're the one in charge of setting those rules up.
Which makes sense, right? It's your data, your application, so you need to be the one controlling who can access them. But let's say I set up a web server in the cloud, just like we talked about earlier, and I try to get to my website, but it's blocked. What's going on there?
Remember that default deny principle we were talking about? Well, it applies in the cloud too. Until you specifically create an NSG rule that allows HTTP traffic, your web server is basically invisible to the outside world.
So it's not actually a glitch, it's a security feature. So to fix that, I'd go into my NSG settings, create a new inbound rule allowing HTTP traffic from anywhere, and bam, my website is live.
Exactly, you got it. And this brings up another super important concept for the CCSP exam, the shared responsibility model. The cloud provider secures the infrastructure, but you're responsible for securing anything you put on top of it. Understanding that is absolutely key for the exam.
Right, so you can't just assume that because it's in the cloud, the provider will handle all the security stuff in the cloud. We're all in this together.
Yeah,
And we all need to understand what we're responsible for.
exactly. And speaking of connections, let's move on to VPNs. Now, VPNs, they're all about creating secure tunnels. It's like sending your data through a secure tunnel through the internet. But the CCSP exam wants you to go deeper than just knowing what a VPN is.
Right, we need to understand the different types of VPNs, how they actually work, and why certain VPN choices are better for security than others. For example, I know there are site-to-site VPNs that connect entire networks together, and then there are remote access VPNs that let individual users connect securely from wherever they are.
You're on the right track there. You can think of site-to-site VPNs like building a secure bridge between two castles, and remote access VPNs are like giving each knight their own personal teleportation device so they can securely beam into the castle network from anywhere.
That's a pretty vivid picture. So both types of VPNs are creating that secure tunnel, but they're used in very different ways. And I know that the magic behind all of this secure tunneling is encryption. You're basically scrambling the data so anyone trying to eavesdrop just sees gibberish. But how do you actually pick the right kind of encryption for a VPN?
Well, there are two main protocols you need to know for the CCST exam, IPsec and SSL/TLS. IPsec is really powerful. It's often used for those site-to-site VPNs and for connecting to cloud services. It's like having a heavily armored convoy protecting your data.
Okay, so IPsec is like the Fort Knox of VPN protocols.
Yeah.
What about SSL/TLS?
SSL/TLS is the same technology that secures websites and online transactions. It's more common for those remote access VPNs because it's easier to set up, and it works with pretty much any device.
So IPsec is like the high security option. And SSL/TLS is more about ease of use and making sure it works with everything. But either way, you're still creating that secure tunnel to protect your data as it travels over the internet.
Exactly. But here's where it gets interesting, and where the CCSP exam really digs into the details. We have to talk about the different ways that you can set up these VPN connections. Things like full tunnel versus split tunnel.
Okay, let's unpack that. Full tunnel, that sounds pretty straightforward. All your traffic goes through the VPN, maximum security. But split tunneling, that seems a little more tricky. You're basically choosing which traffic goes through the secure tunnel and which traffic just goes straight out to the internet.
Exactly. And split tunneling might seem more efficient at first glance, but it can introduce some security risks. And the CCSP exam really wants you to be aware of that. If it's not set up correctly, split tunneling can create leaks in your security, allowing sensitive data to bypass the VPN protection. It's like having a secret passageway, but you accidentally left the door open.
So even though split tunneling might be tempting, because it can be a bit faster, you're kind of making a trade-off there and potentially compromising on security. And that's something the CCSP exam definitely cares about.
Definitely. You have to understand those trade-offs. You have to understand those potential vulnerabilities, and also why a lot of organizations are moving towards always-on VPNs so that everything is protected all the time.
Always on VPNs, that makes a lot of sense. You're taking the decision out of the user's hands and just making sure all their traffic is protected all the time.
Sure.
But even with a super secure VPN, you still need other ways to protect your network itself, right? That's where intrusion detection and prevention systems come in.
Exactly. You can think of these systems, IDS and IPS, as the watchful eyes of your network. They're always analyzing traffic, looking for anything suspicious that could mean someone is trying to attack you.
So it's like security cameras and motion sensors for the digital world, except they're way smarter. They're not just looking for movement, they're actually looking at patterns of behavior to spot hackers.
Exactly. And the CCSP exam really wants you to understand the difference between IDS and IPS. IDS is like a burglar alarm. It alerts you when something bad is happening. IPS is more like a guard dog. Not only does it detect the intruder, it actually tries to stop them.
Okay, so IDS is passive, it raises the alarm, but it doesn't actually do anything to stop the problem. IPS is active, so it actually tries to block or contain the threat. But how do these systems know what's bad in the first place? Do they have some kind of cyber intuition?
They use a few different techniques, and the CCSP exam wants you to know about both of the main ones. There's signature-based detection, And there's anomaly-based detection. Signature-based detection is kind of like having a list of all the known bad guys. The system looks for anything that matches a known attack pattern.
So it's like having a fingerprint database for cyber attacks. You can easily spot the usual suspects. But what about those new attacks, the ones that nobody's seen before? That's where anomaly-based detection comes in, right?
Exactly. Anomaly-based detection is all about creating a profile of what normal behavior looks like on your network. And then it flags anything that's unusual or out of the ordinary. It's kind of like noticing that someone who always wears sweatpants suddenly shows up in a three-piece suit. You know something's up.
Right. It's all about spotting those weird things that deviate from the norm. But doesn't that mean that anomaly detection could trigger a lot of false positives? I mean, sometimes people change their wardrobe, and it doesn't mean they're a hacker.
Yeah, that's a valid point. Anomaly detection definitely needs to be tuned carefully, and you need to understand its limitations, but it's also one of the most effective ways to catch those brand new attacks that signature-based systems might miss.
So you need to use both methods strategically, right? Know their strengths, know their weaknesses, and know how they work together. And I'm guessing that's something the CCSP exam would ask about.
Absolutely. And speaking of strategic approaches, there's no bigger shift in security thinking than the zero trust model. And this is a huge part of the CCSP exam.
Okay, zero trust, everyone's talking about it. But it can be kind of hard to wrap your head around. Is it really about not trusting anyone like some kind of digital paranoia?
Not exactly. It's about shifting the focus from trusting networks to trusting authenticated individuals and devices. Instead of assuming everything inside the network is safe, you verify every single access request, no matter where it's coming from.
So it's less about no trust and more about always verify. Even if someone's already inside the network, kind of like how airport security screens everybody, even the pilots.
Exactly. And this shift in thinking requires a whole new set of tools and technologies. You need strong identity and access management, IAM, to verify who's who. You need security information and event management, SAWAME, to constantly watch for suspicious activity. And you need security orchestration, automation, and response, SOAR, to automate how you respond to incidents.
Okay, so zero trust isn't just one thing. It's a whole bunch of things working together. Each part plays a crucial role in verifying access, monitoring for threats, and responding quickly if something bad does happen.
Exactly. And we'll dig into all the nitty-gritty of zero trust and how it all works together in the next part of our deep dive.
Sounds good. It's clear that acing the CCSP exam is about way more than just knowing the definitions. You have to understand the logic, you have to know the trade-offs, and you have to be able to apply these concepts to real-world scenarios. It's a lot to learn, but that's what makes this journey so interesting.
Absolutely. It's about thinking critically, connecting the dots, and seeing that big picture of cloud security.
And on that note, we're going to take a quick pause here. Don't worry, we'll be right back for part 2. We'll dive even deeper into these essential concepts then.
Stay tuned. Welcome back to our CCSP deep dive into network security. We covered the basics of firewalls and VPNs, but now we have to dig into some of the more complex stuff that the exam might throw at you.
Complex stuff. You mean we're going beyond just the basics? Bring it on. I'm ready for a challenge. We talked about firewalls being the first line of defense, right? But I know there's more to it than just those big network firewalls. What about those host-based firewalls? How do they fit into the picture, especially when it comes to the CCSP exam?
Great question. Host-based firewalls are like having a bodyguard for each individual device on your network, whether it's a server, a laptop, or even a smartphone. They add another layer of protection, controlling traffic at a more granular level.
So it's like you're not just guarding the walls of the castle, you're also making sure each room inside the castle is secure.
Yeah.
But why would you need both? Isn't a network firewall enough?
Well, what happens if the network firewall gets compromised? Or if an attacker manages to sneak in through some other way? Host-based firewalls act like a backup security system. They can limit the damage an attacker can do. They can stop malware from spreading, block those unauthorized access attempts, and even protect against attacks that come from inside the network itself.
So it's all about defense in depth, right? Having multiple layers of security to catch anything that might slip through the cracks. That's definitely a theme we see a lot in the CCSP exam.
Absolutely. They want to make sure you understand how important it is to have multiple layers of protection. And speaking of firewalls, there's another important thing to think about when it comes to the CCSP exam, the whole open source versus proprietary solutions debate.
Ah, yes, the classic open source versus proprietary debate. But how does that apply to firewalls? And why is it relevant to the CCSP?
Think about the real-world implications. Open source firewalls give you a lot of flexibility and control, but they also require a lot more technical expertise to set up and maintain. Proprietary solutions are usually more user-friendly, and they come with vendor support, which can be really helpful, but they can be more expensive, and you might have fewer options for customizing them to your specific needs.
So it's that classic trade-off, right? Control versus convenience, cost versus functionality. And the CCSP wants to make sure you understand these trade-offs when you're choosing a firewall solution.
Exactly. They want to see that you can think strategically about security, consider the specific needs of the organization, and make informed decisions.
Okay, so open source versus proprietary. What other firewall nuances does the CCSP exam focus on?
Deployment methods are a big one. Traditionally, firewalls were physical hardware appliances, those big boxes sitting in a server rack. But now we have virtual appliances as well.
So it's the same concept as virtualizing servers, right?
Well,
You're running the firewall software on top of a virtual machine.
Exactly. Virtual appliances are great, especially for companies that are moving to the cloud. They're more flexible, they're more scalable, and they're often more cost-effective than those traditional hardware firewalls.
So again, it's all about choosing the right tool for the job. Hardware versus virtual, open source versus proprietary. What are some of the key things you should think about when you're evaluating any firewall solution, regardless of how it's deployed?
Performance is absolutely crucial. The CCSP wants to make sure you understand that a firewall shouldn't slow your network down. It needs to be able to keep up with all the traffic that's flowing through it without creating a bottleneck.
Right. The last thing you want is for your security solution to actually cause performance problems. So performance is key. What else?
Scalability is another important factor. A company's needs can change over time, and the firewall should be able to keep up with that. Can it handle a sudden increase in traffic? Can it accommodate more complex rules as your network grows? These are the kinds of questions the CCSP exam might ask you to think about.
So it's not just about meeting your current needs. It's also about planning for the future and making sure your security solutions can grow with you.
Exactly. And of course, the CCSP exam goes into a lot of detail about the actual features and functionality of different firewall solutions. We're not just talking about basic packet filtering anymore. We're talking about next generation firewalls or NGFWs. These are the big leagues of firewall technology.
Okay, NGFWs. Those are the ones that everybody's talking about. What makes them so special, and why are they such a big deal for the CCSP exam?
NGFWs go beyond just looking at basic stuff like IP addresses and ports. They can actually understand application-level traffic. They use techniques like deep packet inspection, which means they can actually look at the content of the data that's flowing through them.
So instead of just checking the envelope, they're actually reading the letter inside to see if there's anything malicious going on.
That's a great way to put it. This deeper level of inspection lets NGFWs do some really cool stuff. They can identify specific applications, they can track individual users, and they can even understand the content of web traffic. That means they can block threats that would slip right past a traditional firewall, and they can enforce much more granular security policies based on what's actually happening with the data.
It's like having a security guard that not only checks your ID, but also uses facial recognition and behavioral analysis to spot potential threats.
Exactly. And the CCSP exam wants to make sure you understand how to use all of these advanced NGFW capabilities to build a really secure network environment.
Okay, so NGFWs are definitely a step up in terms of security and sophistication, but I'm guessing they're also more complex to manage.
They can be, yeah. But the added security they provide usually outweighs that complexity. And vendors are making them more user-friendly all the time, with intuitive interfaces and automation features that make them easier to manage.
So it's like having a powerful sports car. It might take a little more skill to handle,
Mm-hmm.
but the performance and handling are definitely worth it.
Exactly. And as cyber threats keep getting more advanced, NGFWs are becoming more and more essential for keeping networks safe.
All right, so we've covered a lot of ground on firewalls, but I want to circle back to VPNs for a minute. We talked about the different types of VPNs and the protocols they use, but there's one aspect that's particularly important for the CCSP exam: the difference between VPN concentrators and VPN gateways.
You're right. That's a key distinction for anyone who's working with VPNs in the cloud. A VPN concentrator is a dedicated appliance. It's specifically designed to handle huge volumes of VPN traffic. Think of it like a super high-speed router that's optimized for secure remote connections.
So it's a purpose-built piece of hardware, all about VPN performance and efficiency. Makes sense for big organizations that have a lot of people using VPNs all the time. What about VPN gateways?
VPN gateways are often software-based. And they can be integrated into existing network devices like firewalls or routers. They're a more cost-effective option, especially for smaller companies that don't need the raw power of a dedicated concentrator.
So it's like adding VPN capabilities to your existing tools rather than buying a whole new set of tools. And I'm guessing the CCSP exam wants us to understand these different approaches. And when you might choose one over the other?
Exactly. It's about showing that you can assess the needs of an organization and choose the right VPN solution based on factors like cost, performance requirements, and how complex their network is.
Right. It's all about those real-world decisions. Picking the best solution for the situation. But whether you go with a concentrator or a gateway, what are some of the key things to keep in mind when you're setting up any VPN?
Security always comes first. The CCSP will test your understanding of things like strong encryption algorithms, multi-factor authentication, and features like split tunneling and kill switches, which we talked about earlier.
Right, split tunneling can be risky if it's not configured correctly.
Right.
Like that secret passageway with the door left open, not exactly ideal for security.
Uh-uh.
And kill switches, those sound pretty intense.
A kill switch is like an emergency brake for your VPN. If the VPN connection drops for any reason, the kill switch immediately cuts off your internet access, so no data can leak out of that secure tunnel.
So it's a last resort to protect your data if something goes wrong with the VPN connection. Makes sense. But what if the VPN connection is just slow all the time? Is that a problem?
Absolutely. Performance is super important for VPNs, especially in the context of the CCSP exam. A slow VPN can really hurt productivity and lead to frustrated users. So it's important to choose a provider that has a good track record for speed and reliability.
It's like having a car with a powerful engine. It needs to be able to handle the load without stalling out.
Exactly. And don't forget about ease of use. The VPN should be simple to set up and manage, even for people who aren't tech experts. If it's too complicated, people might just avoid using it altogether, which defeats the whole purpose of having a secure connection in the first place.
Right. User adoption is key. The best security solution in the world is useless if nobody actually uses it.
Yeah.
But what about people who are always on the move, using their smartphones and tablets? That's where mobile VPNs come in, right?
Absolutely. Mobile VPNs are designed specifically for those devices. They offer the same security benefits as regular VPNs, but they're optimized for mobile networks.
So it's like having a VPN that's as mobile as you are, protecting your data wherever you go. But why do you need a separate mobile VPN? Can't you just use a regular VPN on your phone?
You technically could, but mobile VPNs are usually lighter and more efficient, so they don't drain your battery as quickly. And they often have features like automatic connection, so you don't have to remember to turn the VPN on and off every time you switch networks.
So it's all about making security seamless and convenient for people who are always on the go. But VPNs, even mobile ones, are just one piece of the puzzle when it comes to securing networks, right? Especially for the CCSP exam. What other tools and techniques do we need to have in our security toolbox?
Well, one really important area is intrusion detection and prevention, or IDP for short. These systems are like the watchful guardians of your network. They're always on the lookout for any signs of trouble.
Right, IDS is like a burglar alarm. It lets you know when something bad is happening.
Yeah.
And IPS is like a guard dog. It actually tries to stop the intruder. But how do these systems actually work? How do they know what's normal and what's not?
They use several different techniques, but two of the most important ones for the CCSP exam are signature-based detection and anomaly-based detection.
Right, we talked about those earlier.
Signature-based detection is like having a database of known bad guys. It can catch a lot of those common attacks that use predictable patterns.
So it's like having a fingerprint database for cyber criminals. You can easily spot the repeat offenders. But what about those brand new attacks, the ones that nobody's seen before? How do you catch those?
That's where anomaly-based detection comes in. It's about figuring out what normal behavior looks like on your network, and then flagging anything that deviates significantly from that norm. It's like having a security camera that not only detects movement, but also analyzes how people are moving to see if they look suspicious.
So it's all about recognizing patterns, deviations, anything out of the ordinary.
Yeah.
But with anomaly detection, wouldn't you get a lot of false positives? Sometimes network traffic just acts differently for legitimate reasons.
True. That's one of the challenges with anomaly detection. You need to tune it carefully and understand its limitations. But it's also one of the best ways to catch those zero-day attacks, the ones that signature-based systems would miss.
So you need to use both methods strategically, know their strengths, know their weaknesses, and understand how they work together. And I'm guessing the CCSP exam wants us to be able to make those kinds of judgments.
Absolutely. The exam is all about showing you can think critically about security. way different options, and make smart decisions based on the situation.
Okay, so we've got our firewalls, our VPNs, and our intrusion detection and prevention systems working together to protect the network. But even with all of those defenses, we still need to think about how we structure our network itself to minimize the impact if someone does manage to break in. That's where network segmentation comes in, right? Got it. Network segmentation is a key concept for the CCSP exam. It's about dividing your network into smaller, isolated zones, each with its own security policies and controls. So instead of treating the entire network like one big happy family,
Yeah.
we're creating smaller, more secure compartments. But why is that so important for security?
Well, think about it this way. If an attacker does manage to get into one part of your network, segmentation can stop them from easily moving laterally to other areas. It's like having fire doors in a building. They can contain a fire to one section and prevent it from spreading to the whole structure.
Okay, so it's all about limiting the damage, even if someone does manage to breach your defenses. But how do you actually go about segmenting a network? What are the key things to think about?
Well, you need to carefully assess your network, figure out where your most important data and systems are, and then group them into different zones based on how sensitive they are and how much they need to talk to each other.
So it's like designing a secure facility, right?
Yeah.
You're deciding where to put the most valuable stuff and how to control access to different areas.
Exactly. And once you've defined your network segments, you need to set up clear security policies for each zone. Rules about who can access what kind of traffic is allowed, and what security controls are in place.
So it's like having different levels of security clearance for different parts of a building. Only authorized personnel can get into those sensitive areas. But network segmentation sounds pretty complex. Is that something that only big companies with dedicated security teams can do?
Not necessarily. While it can get complex, network segmentation can be implemented at different levels, even for smaller companies. The important thing is to start with a good understanding of your network and gradually introduce segmentation based on your specific needs and resources.
Okay, so it's about being strategic, starting with the basics and then getting more sophisticated as you go. But even with the best segmentation in place, there's always the possibility of human error, right? People clicking on phishing links, accidentally downloading malware, that sort of thing. That's where security awareness training comes in.
Absolutely. Security awareness training is crucial for any organization, no matter how big or small, no matter what industry you're in. It's about teaching your employees about security, helping them understand how to recognize threats and how to avoid them, so they can be part of the solution, not part of the problem.
Right, it's about making security everyone's responsibility,
Yeah.
not just something that the IT department has to worry about. But what kind of things should security awareness training cover?
It should cover a wide range of topics. Everything from basic password hygiene and phishing scams to more advanced stuff like social engineering and safe browsing habits. The goal is to give people the knowledge and skills they need to make smart security decisions, both at work and at home.
Because those security breaches can happen anywhere, anytime. It's not just about protecting the corporate network. It's about building a culture of security that extends beyond the office walls.
Exactly. And security awareness training shouldn't be a one-time thing. It needs to be an ongoing program with regular reminders, updates, and interactive exercises.
So it's like those fire drills that everyone hates, but that are actually really important. Practice makes perfect, even when it comes to security. But even with the most security-aware employees, you still need constant vigilance, right? You need to be able to spot those threats that might slip through the cracks. That's where network monitoring and analysis come in.
Exactly. Network monitoring and analysis are essential for proactive threat detection. It's like having a surveillance system that's watching everything that's happening on your network, alerting you to any suspicious activity.
So it's like having security cameras that record everything, so you can review the footage and identify potential threats. But with all the data that flows through a network, how do you make sense of it all?
That's where network analysis tools come in. They can help you sift through mountains of data and identify patterns, anomalies, and potential threats that might otherwise go unnoticed. It's like having a team of detectives who are trained to spot those tiny clues that might indicate a criminal's true intentions.
So it's about using technology to help human analysts focus on the most important alerts and investigate potential threats more efficiently.
Exactly. Network monitoring and analysis are crucial for staying ahead of the curve, identifying and responding to security incidents before they can turn into major breaches.
Okay, so we've got our monitoring and analysis systems in place. But what happens if, despite our best efforts, a security breach does happen? That's where incident response planning comes in, right?
Absolutely. Having an incident response plan is a crucial part of any comprehensive security strategy, and it's a big part of the CCSP exam. It's like having a fire escape plan. So if a fire breaks out, everyone knows what to do and where to go to stay safe.
So it's like a step-by-step guide for what to do when something bad happens. But what does an incident response plan actually involve?
It outlines all the steps you need to take when there's a breach, starting with figuring out exactly what happened and how bad it is. Then you need to contain the damage, get rid of the threat, recover any affected systems, and learn from the experience so you can prevent the same thing from happening again.
So it's not just about putting out the fire. It's also about figuring out how the fire started, cleaning up the mess, and making sure it doesn't happen again. But even with the best incident response plan, prevention is always better than cure, right? What can we do to make our networks more secure in the first place, to make it harder for attackers to even get in?
One of the most fundamental things you can do is security hardening. This is about locking down your network devices and applications, getting rid of any unnecessary services, closing unused ports, implementing strong security configurations, basically reducing the attack surface as much as possible.
So it's like reinforcing the doors and windows of your house,
Yeah.
making it harder for burglars to break in. But security hardening sounds like a lot of work, especially with so many devices and applications to manage.
It can be, but it's essential for building a solid security foundation. There are tools and best practices that can help. The key is to be systematic, focus on your most important systems first, and follow industry standards and recommendations.
So security hardening is about making your network as impenetrable as possible. But what about those really sophisticated attacks that target specific vulnerabilities? Or the ones that use social engineering to trick users into giving up sensitive information? How do you defend against those?
That's where advanced threat protection comes in. It's about going beyond those traditional security measures and using more sophisticated tools and techniques that can detect and block those evasive threats, the ones that are constantly changing and getting harder to catch.
So it's like having a security system that not only protects your house, but also keeps an eye on the whole neighborhood, looking for suspicious activity and potential threats before they even reach your doorstep. What kind of technologies are we talking about here?
Advanced threat protection solutions usually use a combination of different approaches. Things like sandboxing, behavioral analysis, machine learning, and threat intelligence.
Okay, let's break those down. What do each of those things do, and how do they all work together?
Sandboxing is like having a safe place where you can detonate a suspicious package to see what's inside without risking any damage. In cybersecurity, sandboxing means running suspicious files or code in an isolated virtual environment to see how they behave and figure out if they're actually dangerous.
So it's like having a virtual bomb squad. They can safely analyze those potential threats without blowing up your entire network. Makes sense. What about behavioral analysis?
Behavioral analysis is like profiling a suspect based on their actions and patterns. In cybersecurity, behavioral analysis tools watch your network traffic and user activity, looking for anything that deviates from normal patterns, anything that might indicate malicious intent.
So it's like having those detectives who are trained to spot those tiny clues, the ones that might reveal what a criminal is really up to.
Exactly. But with all the data that's flying around these days, it would be impossible for humans to analyze all of it. That's where machine learning comes in. Machine learning uses algorithms to analyze massive amounts of data, to find patterns and learn to recognize malicious activity, even when it's hidden or disguised. It's like having a supercomputer that can sift through all that information and find those tiny needles in a haystack.
That's amazing. But even with all of that technology, wouldn't it be helpful to have some inside information, to know what the bad guys are up to, what their latest tricks are, and what vulnerabilities they might be targeting?
Absolutely. That's where threat intelligence comes in. Threat intelligence gives you up-to-date information about all the latest threats, vulnerabilities, and attack techniques. It's like having a network of spies who are gathering information about the enemy's plans, so you can anticipate their next move and prepare your defenses.
So threat intelligence helps to keep all those other advanced threat protection technologies informed and effective. It's like having the latest intel to guide your security strategy.
Exactly. All of these technologies, sandboxing, behavioral analysis, machine learning, and threat intelligence, work together to create a powerful defense against those really advanced threats that are always evolving and getting more sophisticated.
So it's like having a multi-layered defense system, each layer reinforcing the others and making it much harder for attackers to succeed. But these advanced threat protection solutions sound pretty complex and expensive.
Yeah.
Are they only for big companies with huge security budgets?
Not necessarily. While some solutions can be complex and require specialized expertise, there are also cloud-based solutions that offer similar capabilities on a subscription basis. These cloud-based solutions make advanced threat protection much more accessible to smaller organizations that don't have the resources to build their own in-house security teams.
So it's like being able to hire a whole team of security experts without actually having to hire them. That's pretty awesome.
Yeah,
But I'm sure the CCSP exam wants us to understand the trade-offs involved, the pros and cons of each approach.
definitely. The exam is all about showing you can analyze different solutions, understand their strengths and weaknesses, and make the best decision for each situation.
Right. It's not about memorizing a bunch of technologies. It's about knowing how to use them strategically to create a secure environment. Speaking of strategy, I think it's time to tackle one of the most important concepts for the CCSP exam, the shared responsibility model.
Absolutely. That's a crucial one. The shared responsibility model is all about understanding who's responsible for what when it comes to cloud security. It's a partnership between you, the cloud customer, and the cloud provider. But it can be a little confusing to figure out where the lines are drawn.
So let's clear up that confusion. What do you mean by shared responsibility? Who's responsible for what?
It definitely can be confusing, and that's why it's such a big deal for the CCSP exam. The key is to remember that the cloud provider is responsible for the security of the cloud, meaning they handle the underlying infrastructure, the physical data centers, the hardware, the network, all the foundational stuff that makes the cloud platform itself secure.
So the cloud provider takes care of the building, the walls, the plumbing, all of that. What about all the stuff that we, the customers, put into the cloud?
That's where your responsibility comes in. You're responsible for the security in the cloud. Your data, your applications, your operating systems, your configurations, everything you bring to the party.
So it's like renting an apartment. The landlord takes care of the building, but I'm responsible for securing my own apartment, locking the doors, installing an alarm system, and being careful about who I let in.
Exactly. That's a perfect analogy. And understanding this division of responsibility is super important for the CCSP exam. They want to see that you know what you need to focus on to protect your organization's stuff in the cloud.
Okay, so no more passing the buck and saying, oh, it's in the cloud, the provider will handle it. We have our own part to play, and it's a big one. But what are some specific examples of things that fall under our responsibility as the cloud customer?
We've already talked about a lot of them. Configuring your network security groups, managing your firewalls, setting up your VPNs, implementing intrusion detection and prevention systems, all of those are your responsibility.
So all of those security best practices we've been discussing aren't just nice to haves. They're essential for fulfilling our end of the shared responsibility model agreement.
Exactly. And it doesn't stop there. You're also responsible for data encryption, identity and access management, vulnerability management, security awareness training. All of those are crucial aspects of security in the cloud that are your responsibility.
So it's like a checklist of security to-dos. We need to make sure our part of the cloud is just as secure as the infrastructure it's running on.
Exactly. And here's another important thing to remember for the CCSP exam. The shared responsibility model isn't static. It changes as cloud services and technologies change. As new services emerge, those lines of responsibility might shift. So you need to stay informed and adapt your security practices accordingly.
So it's not a set it and forget it kind of thing. We need to keep up with the changes in the cloud world and adjust our security measures to match.
Absolutely. And understanding the shared responsibility model isn't just about technical stuff. It's also about building a culture of security within your organization, making sure that everyone understands how important it is to protect sensitive data and systems in the cloud.
So it's about shared responsibility, not just in terms of who does what technically,
Yeah.
but also in terms of making sure everyone in the organization is on board with security.
Exactly. Everyone from developers and system administrators to business users and executives needs to understand the importance of cloud security and their role in keeping the cloud environment safe.
That's a great point. I think that's a good place to wrap up this part of our deep dive. We've covered a ton of ground exploring all sorts of network security concepts, from the basic building blocks to the shared responsibility model. But I hope our listeners are starting to get a better grasp of what it takes to secure networks in today's complex world.
And remember, this is just the beginning of your journey to becoming a certified cloud security professional. Keep exploring, keep learning, and keep those networks safe.
We'll be right back for the final part of our deep dive,
Yeah.
where we'll cover even more essential concepts for the CCSP exam.
Stay tuned.
All right, welcome back to our CCSP Network Security Deep Dive. We've covered firewalls, VPNs, intrusion detection, even that tricky shared responsibility model. But for this last part, let's zoom in on a few more concepts the CCSP exam loves. Things like vulnerability management, data loss prevention, and then all those acronyms: CM, SOAR, CASP, EDR.
It's like they want to make sure you're not just memorizing definitions. They want to see you can actually apply this stuff. Like vulnerability management, everyone says patch your systems right. But for the CCSP, you got to go deeper, understand the whole process, why it's oh so crucial in the cloud.
Okay, so it's more than just running a scan and calling it a day. What are some of the key steps if you want a good vulnerability management program, especially for cloud security?
First off, you got to know what you've got on key. Asset inventory. It's essential. Can't secure what you don't even know exists. So identifying all your cloud resources. Virtual machines, containers, storage, databases, the whole shebang.
Like taking inventory of your entire cloud kingdom, making sure no vulnerabilities are hiding in some forgotten corner.
Precisely. Then comes the scanning part. You use tools to find weaknesses in your systems, apps, all that. But the CCST exam takes it further. It's not just finding them, it's figuring out which ones matter most.
So not all vulnerabilities are equally dangerous. You can't just patch every single thing all at once. How do you figure out where to start?
Risk assessment. Got to consider how bad the vulnerability is, how much damage could an attacker do if they exploit it, and how likely are they to even try. A critical flaw on a public web server. Way higher priority than some minor thing buried deep inside your network.
So it's like triage, but for security. You got to focus on the most urgent cases first.
Exactly. And once you got your priorities straight, then you got to fix them. Patching, updating configs, sometimes putting other controls in place if you can't patch right away.
So it's a cycle, right? Find the flaws, figure out which are worst, fix them. And this never really ends, does it? New vulnerabilities pop up all the time.
Vulnerability management is a marathon, not a sprint. That's what the CCSP wants you to get. It's ongoing. You got to build a program that can adapt because the cloud changes fast.
Got to stay on top of it, always adapting to the new threats. But even with perfect vulnerability management, sometimes breaches still happen. Data loss prevention, that's the next line of defense, right?
DLP, yeah, another big one for the CCSP. Protecting that sensitive data, not just from being stolen, but from unauthorized access, changes, being deleted, the whole 9 yards.
So it's control over the data, making sure it doesn't end up where it shouldn't. But how do you actually DLP in the cloud? Data's everywhere these days.
DLP solutions, they usually work by identifying the important data, then watching where it goes. Then they enforce rules to stop unauthorized stuff, like sharing or access. Think encryption, access controls, data masking, sometimes even blocking certain file transfers or emails if they've got sensitive stuff in them.
Like a super strict librarian, making sure nobody's checking out books they're not supposed to.
Yeah, and in the cloud, DLP is even more important because data's spread out, access from who knows where, shared in a million ways. You need a DLP solution that can handle that complexity, protect data consistently everywhere.
You got to be able to see it, control it, no matter where it is in the cloud.
Mm-hmm.
But like vulnerability management, there's no single right answer for DLP, is there?
Nope. Each company's got to figure out what works for them. And the CCSP exam, they'll give you scenarios where you got to evaluate different DLP solutions, figure out their pros and cons, pick the best one for that specific situation.
So it's applying the knowledge, not just reciting definitions. Speaking of which, let's tackle those security acronyms. SUM, SOAR, CAB, EDR. It's like alphabet soup. What do they mean? Why do they matter for cloud security?
It's our secret cybersecurity language, but don't worry, we'll decode it. First up, SIME, Security Information and Event Management. This is like the central nervous system for your security. It gathers logs, alerts, all that stuff from your firewalls, intrusion detection, servers, everything. Then it looks for patterns, weird stuff, anything that could mean a security incident.
So tons of data coming in, and SIME helps make sense of it all.
Yep, puts the pieces together. But once you spot a problem, what then? That's where SOAR comes in, security orchestration, automation, and response. SOAR takes those SIME insights and automatically reacts to security events. It can trigger things, run scripts, even talk to other security tools to contain the threat, minimize damage.
So like a team of instant response security experts, but it's all automated. No waiting for humans to react.
Exactly. SIEM and SOAR, they work as a team to streamline security. You get real-time visibility, automated responses, crucial in today's world where threats move fast. But remember, we're in the cloud now. Data isn't just tucked away safely behind your network walls anymore. So we need CASB, Cloud Access Security Broker.
Okay, CASB, got it. What's that one do? Why is it so cloud specific?
Think of it as the security guard for your cloud apps. It sits between your users and those cloud services. Make sure everyone's following the rules, monitoring activity, keeping that sensitive data safe from prying eyes.
So a guard for all those cloud interactions. Makes sense. But CASB focuses on apps.
Yeah.
What about the actual devices people are using to access them?
That's where EDR steps in, endpoint detection and response. It watches what's happening on those devices, looking for bad behavior, and can even automatically contain or fix threats. An extra layer of protection, making sure even if an attacker slips through, they can't easily take over those devices.
So it's antivirus plus security guard, always on the lookout on each device.
Wow, so many different security solutions. Hard to keep track of it all sometimes.
It can feel that way, but they all work together. A layered approach, different tools for different parts of the cloud security puzzle. And that's what the CCSP exam is about, understanding how it all fits together. Seeing the big picture, how these technologies work as a team, that's a lot to cover. We've explored so much, from the basics of firewalls to this whole alphabet soup of security solutions. Any final words of wisdom for our listeners as they get ready for the CCSP exam?
Cloud security, it's a journey, always changing. Threats evolve, new tech pops up, how we use the cloud changes constantly. You got to keep learning, stay curious, keep asking questions. That's the key to being successful in this field.
It's not just about the certificate. It's about that deep understanding, always adapting to the challenges.
The CCSP is a great start, but the real reward is the knowledge you gain and the ability to use that knowledge to protect your organization and its data.
Well said. That wraps up our network security deep dive. Hope you all feel more prepared for the CCSP exam and for your careers in cloud security.
Thanks for listening. Keep those clouds secure out there.